Hey grade 12s and welcome to this video. So in this video we are going to be working on the grade 12 November 2024 paper 1. Now I know I'm uploading this video really early, but I'm going to be a little busy next year, so I just decided why not upload it as soon as possible. So this exam is worth 150 marks and the time allocated to this paper is 3 hours. Also, please take note that I'm going to be uploading this video in parts. So you're probably looking at the algebra section right now, and then I will also upload the other ones and just roll them out. It's just easier to export like this, and that's why I'm going to do that. Okay, moving on to the instructions. You know the drill by now. Just make sure to round off to 2 decimal places unless stated otherwise. And remember, diagrams are not necessarily drawn to scale. So even if it looks like the graph is passing 1, for example, on the y-axis, and they don't tell you that it's passing 1, then you cannot assume that it is. You would have to first prove that it is. Okay. So without further ado, let's get into this video. So we start off with the first question in question 1, which tells us to solve for x if we are given this equation. So as you can already see, one hand side is equal to 0. So we can go ahead and say the first factor, so the first value that is being multiplied, is either equal to 0 or the second value, which is the x minus 3, is equal to 0. And of course, if you take your negative 3 over, it means that x is equal to 3. And those will be our answers. And that's why it's just 2 marks, because they factorized it for you. Moving on to the next question. The next question, 1.1.2, says we need to solve for x again, but this time correct to 2 decimal places. And you know that when they say that, they're really just hinting at use the quadratic formula. So first of all, notice that it's not in its standard form. So we need to take that 4x over. So we have 2x squared and then minus 4x to put it in the order of its exponents. And then plus 1 is equal to 0. Okay, so our quadratic formula looks like this. And now all we have to do is substitute. So x is equal to negative, and you see that the b value, okay, the number in front of x is negative 4. So negative bracket negative 4 plus minus the square root of, and then we have negative 4 squared because that's b, minus 4, and then our a value is 2, and our c value, as you can see, is positive 1. So times 1 all over 2a, and a is 2. So there we go. So just punch that into your calculator, and then we're going to get our 2 solutions for x. Okay, so the answer will be in third form, but in decimal form, that is 1 point. So round off to 2 decimal places, that is going to round up to 71. And then to get the second solution, we're going to change that to a minus, and now we get 0 points, and that is just going to stay 29, okay, because the 2 falls away since it rounds down. So those are our answers, and we move on to the next question. The next question, 1.1.3, we have a trinomial and an inequality that we have. So let's go ahead and factorize since one hand side is already equal to 0. So we have x times x gives you x squared. Now we need factors of negative 3 that can give us negative 2. So 3 is a very easy number to find factors because it's a prime number. It only has 2 factors, 3 and 1. So because this is negative, 1 needs to be negative, 1 needs to be positive. If you make the 3 negative and you make the 1 positive, you know that negative 3 plus 1 is negative 2, and that is the coefficient of the middle term we have. So we know that that is indeed the factors that we have there. Solve. Now we have to go ahead and find the values in this inequality. You can choose to use the table method like I did in this video, or you can use the graph method, which I recommend because, you know, for grade 12s, it really just works better. So we're going to put down our x-axis, and you see that our graph is a concave up parabola because the a value is 1, it's greater than 0. So we have a concave up parabola. Then we need to put down our critical values. The critical values is kind of like just solving for x. So solving for x there, you would really just take the positive 1 over and you get a negative 1. And here you'd get a positive 3. So it's negative 1 and 3. The smaller one is negative 1, so it goes on the left. The bigger one is 3. So they want us to solve for x where the graph is greater than 0. remember that when they're referring to greater than 0, they're referring to the values on the y-axis. Values that are greater than 0 are here. So you only take parts of the graph that has values greater than 0, which would be the top part of the graph. See, if you line these to the y-axis, do you see that all these parts of the graph have values greater than 0? Okay, so that's what we're going to look at. It's this part and that. Now we have to determine the values of x for which these parts of the graph exist. And you see that if you line it down to the x-axis to find out where exactly are these x values, these values are over here on the left-hand side of -1. So they're moving towards that direction. Okay, so you can actually say that these are values that are what? Than -1. These are values that are less than -1. So therefore here, x is less than -1. And you see how the arrow, the direction helps you with the inequality. Okay, and then we're going to do the same thing for 3. So 3, we know that these are the parts of the graph we're looking at. If you line those parts down to the x-axis, you see that it's moving towards the right-hand side of 3. So these are values that are greater than 3. So, or this is where x is greater than 3. Again, the arrow helps you with the inequality. Okay, so these values are not related. They're not pointing towards each other. So you don't have to write them as one single inequality. So that is your answer there. Moving on to the next question. The next question is an exponential equation, 1.1.4, and we need to solve for x. So do you see that in this exponential equation, look at what we have. We have 2 to the power of 2x, 2 to the power of x plus 2, and then of course a minus 32. One thing you should always look for in exponential equations is repetition. Do you see that there is something being repeated in this equation? And that is actually 2 to the power of x. Okay, you have a 2 to the power of x here. Yes, there's a 2 next to it, but it's still 2 to the power of x. You also have a 2 to the power of x here. So what we can do is really just break it up first, break that up, just so that you can see what that is. So let's rewrite this as 2 to the power of 2x minus, and we have 2 to the power of x multiplied by 2 to the power of 2. That's what you would multiply together to get 2 to the power of x plus 2, because the exponents get added since the bases are the same. So minus 32, and really 2 to the power of 2 is really 4. Okay, so it's multiplied by 4 is equal to 0. And then now, because you see that you have something repeating, but you have this scenario where you have 2 to the power of 2x, this is an exponential equation that can be expressed as a quadratic equation. And it's really that one where you have to use the k method. Okay, so what we're going to do is take the thing that is being repeated, right? That 2 to the power of x. And we're going to say, let k be equal to that thing that's being repeated, 2 to the power of x. So wherever we see that, we replace it with k. So we have 2 to the power of 2x here. So technically what that's going to be is, because you have your 2 to the power of x there, right? That stands for your k. And then you still have an exponent of 2. So that's k squared. And then you have minus 2 to the power of x. And you know that is k. So that's really minus k multiplied by 4. Which is minus 4k. That's what we have there. And then minus 32 is equal to 0. So we have a trinomial now. Okay, let's go ahead and factorize this. So k times k is what gives you k squared, so k and k. And then we need factors of 32 that can give us a negative 4 in the middle. Okay, let's take big factors. So I wanted to take 16, but that's a bad idea. 16 times 2 is 32. How about we take 8? 8 times 4 gives you 32. So we need one of it to be negative, clearly, because your factor is negative here. So to make sure that the middle stays negative, give the negative to the bigger factor. So negative 8 plus 4. Negative 8 plus 4 gives you negative 4. So that works out perfectly. So our factors here are negative 8 and positive 4. That's what we have there. And we can go ahead and solve for k first. So it will mean that k is equal to positive 8 or k is equal to negative 4. Now, the question is not to solve for k. The question is to solve for x. So to solve for x, we're going to get what we assigned to k at first, right? Which was that 2 to the power of x. So since we said k was equal to 2 to the power of x, let's replace that now with k. Okay, so 2 to the power of x is equal to 8. Or 2 to the power of x is equal to negative 4. And now we can finally solve for x. So here, to solve, it's an exponential, so the goal is to make the bases the same. So 2 to the power of x is equal to 8 as a base of 2 is 2 to the power of 3. And so now that the bases are the same, we can therefore equate the exponents. So x is equal to 3 there. And then here, 2 to the power of x is equal to negative 4. Unfortunately, it's not positive 4. If it was positive 4, we could make the bases the same. But here we can't make the bases the same because the only base you can get here is negative 2, which is not 2. So this is not possible. And that's not really the reason it's not possible. The reason it's not possible is because you have a positive base raised to an exponent and it gives you a negative number. That's impossible. Okay, even if you took a positive base and you raised it to a negative number like negative 1, that's going to give you a half. If you raised it to negative 2, it's going to give you a quarter. So you see that it's always going to give you a positive number. So there's no way it can give you a negative number. And that's why that part doesn't have any real solutions. And this is our answer. Okay, so that is it for 1.1.4. Moving on to the next question. The next question, 1.1.5, is an equation with surds. Okay, you guys know the drill with equations with surds. Always isolate the surd. So we need to leave the surd alone. Let's just leave it here on this side. And then we can go ahead and take our negative x over. Because it becomes a positive x, I'm just going to put it in front and say this is x plus 2. Okay, we've isolated the surd, and now we need to get rid of that surd so that we can solve for x. So we would get rid of a square root by squaring both sides. That's the opposite of square root. So that's going to break open that root, and we have negative 2x plus 4 is equal to, and then you have to distribute there. So you can choose to do this as x plus 2 times x plus 2, but I try to always take short methods so that I can avoid making mistakes. So here's a quick method. You're going to go ahead and square the first term, and that gives you x squared. And then square the last term, and that gives you positive 4. Then first term multiplied by second term gives you 2x. And then just multiply that by 2, which gives you positive 4x. And there we go. Okay, so that is distributed. And now you see that it's going to form a trinomial. So take everything here over to the right-hand side. So 0 is equal to, and we're going to have x squared plus 4x. And then that comes over and becomes a positive 2x. So 4x plus 2x gives you 6x, so positive 6x. And then you have, let's see, there's a positive 4 here, and then this positive 4 comes over, so they will both cancel. Okay, we could even have canceled that already because they were both the same thing. So now we have a binomial, and the only way we can actually factorize this is by taking out a common factor. So x is out as a common factor because that's exactly what is common, and then open a bracket. What do you have left in the first term if you take out x? You'll be left with x. Okay, you can say x squared divided by x. And then in the second term, what do you have left when you take out x? So 6x divided by x, you're just going to have 6. Okay, so that's what we have there. And then let's solve for x. Something times something gives you 0. It means that the first thing is either equal to 0 or the second thing is equal to 0. And of course, if you take the positive 6 over, it becomes negative. Okay, so these are our two solutions. Now, I mean, this is for 4 marks, so it doesn't even look like they're trying to tell you to still check, but I will still check whether it's correct or not, which ones are correct. So we can do that by saying we're going to use the original equation. It's just easier to start from the original. So minus 2, and in place of x, we will substitute a value for x to find out whether the left-hand side really is equal to the right-hand side. So in this case, it must give us 2. So we're going to say negative 2 times x plus 4 and then minus whatever x is. And it should give us 2. So let's go ahead and try the 0. If you substitute 0 into this, what do we get? Well, negative 2 times 0 is 0 plus 4 is 4. Square root of 4 is 2. And then you have 2 minus 0, which is 2. So this works out. That is definitely a solution. Then we can go ahead and try this. with this negative 6. So minus 6 and minus 6. So that will become a positive 12 plus 4 is 16. Square root of 16 is 4. And now you have these multiplying. You can use a calculator, okay? And so that's going to give you a positive 6, and that's 10. 10 is not equal to 2, okay? 10 and 2 are not the same number. So because the left and the right hand side does not balance, it means that x is not equal to negative 6, but x is equal to 0. Okay, so that is it for 1.1.5. X is equal to 0 is our answer. Moving on to the next question. The next question, 1.2, is a simultaneous equation. We have to solve for x and y when we are given these. Okay, they gave you a linear one. Great, that's like the easiest one they can give you. So when we look at these, let's go ahead and name the equations. You can always just call your linear equation equation 1, and then the other one that they give you equation 2. So we have 2x plus y is equal to 3, and from equation 1 we form equation 3. You see that y is nicely on its own, doesn't have any coefficient other than 1 in front of it. So we're going to make that the subject, and we have 3, take 2x over, it becomes minus 2x. So this is our equation 3, right? And we can go ahead and say substitute equation 3 into the equation you didn't use, equation 2. Okay, so let's go ahead and substitute 3 into 2. So wherever you see y, you're going to replace it with 3 minus 2x. So we have a y squared there. We'll just say 3 minus 2x squared, okay, because that's y squared. Then we have plus, and we have x first, and then y again. So 3 minus 2x is equal to 2. So that is our equation 2. And we can go ahead and solve for x now. Okay, so we have that whole thing where we have a binomial squared. So the quick method, we take the first term and square it, and it gives you 9. Take the second term and square it, you're saying negative 2x squared. Okay, if you say negative 2x squared, it's going to give you positive 4x squared. Then you say the first term multiplied by the second term. 3 times negative 2x is negative 6x. And then you multiply that by 2. So that gives you negative 12x. Okay. And then we have this. We can just distribute here. So it's actually foiling out there. So plus, we have 3x. And then positive x times negative 2x. That gives you negative 2x squared. Might as well just take this over since everything here is going to just be a trinomial or binomial. But we're going to have minus 2 is equal to 0. And let's go ahead and simplify. So we're going to start with the x squareds because it's better to put them in the order of the exponents. So that's going to be 2x squared. That's what it simplifies to. And then the things with x. So we have a negative 12x and a 3x. That's like saying positive 3 minus 12. Positive 3 minus 12 gives you negative 9x. And then lastly, the numbers. We have a positive 9 minus 2, and that gives you positive 7 is equal to 0. Okay, so we have this type of equation where you see that's not actually a common factor, but we can still work on this. So to factorize, you can use the method that you use. The method, I use 2 methods, the factor method and the cross method. Here's this video to show you how to work with the cross method. So I'm just going to use the cross method here. So we're going to look for the factors of 2x squared, which is 2x and x. So 2x times x gives you 2x squared. And then the factors of 7. So that is 7 and 1. You could write it as 1 and 7, but that's not a good idea because when you're multiplying across, and that's why it's called the cross method, because we multiply across. So 2x times 7 is going to be 14x. So you don't want that to be too big. So we're going to write it as 7 and 1 instead. Okay. Also notice now in your trinomial that only the middle is negative, meaning both factors need to be negative. We're really just saying negative 7 times negative 1 gives you positive 7. And only them being added like that would give you negative 9. Okay, so just check if it works. So 2x times negative 1 is negative 2x. And x times negative 7 is negative 7x. That, if you subtract negative 2x minus 7, is negative 9x. Okay, so that does work out. And so we know what our factors are. This is a factor and this is the other factor. So it means we have 2x minus 7 and x minus 1 is equal to 0. Okay, so that's what we have. And now we have to solve for x. So this is 2x minus 7 is equal to 0, or x, well, just take the 1 over, is equal to positive 1. Okay, then here we're going to say, I might as well just take it over here. So it's positive 7 when you take it over, and then divide both sides by 2. Therefore, x is equal to 7 over 2. So these are our values for x. X is equal to 7 over 2, or x is equal to 1. So we've just solved for x, and now we need to find y. You can call this equation number 4. And then lastly, to solve for y, substitute equation 4 into equation 3, because that's the equation where y is the subject. Okay, so that is y is equal to, and this is 3 minus 2x, so 3 minus 2x. And our first x value is 7 over 2, so 7 over 2. Or, and let me just rewrite so I don't forget what that is. So 3 minus 2, and then in place of x, you're going to put your second x value, which is 1. Okay, so simplify, you can just use a calculator. But here, you see that there's 2 and 2. So on the denominator and the numerator, they cancel. So that's 3 minus 7, which is actually negative 4. Or y is equal to negative 2 times 1 is negative 2. So 3 minus 2 is 1. So there, these are our solutions. So we have negative 4 and positive 1. Okay, so that is it for the simultaneous equation. And then we move on to question 1.3. Okay, question 1.3 says, consider the product, and we have the product. So consider the product, and we have 1 plus 1 over 2, 1 plus 1 over 3, 1 plus 1 over 4. So you can see how the pattern is going, 1 plus 1 over 5, and it just keeps going. And they tell us that each factor in the product is of the form 1 plus 1 over n. Each factor. So because they're being multiplied, each of it will be called a factor. So each of these have this form. That's what they're really saying. And they say it's for where n is greater or equal to 2. And we can see that is true because, see, this is n. And you see that it starts where n is equal to 2. And then it's all values that are greater than 2. Okay, so they're just stating what we have there. Then they say determine all the values of n. So solve for n. Determine all the values of n for which the product will be an integer value. Interesting question. Now, the thing about this one is I feel like I've seen this before, honestly speaking. Like, this doesn't seem like a new thing they brought in. I will still check which paper exactly I saw it in. If I don't find it, sorry about that, but I really feel like I've seen this before. Okay, but let's just focus on their question. Their question is you need to find all the values of n for which the product will be an integer value. Let's focus on what the product means. Remember how I said these things that we have here? These are factors. And when you multiply these factors, they give you the product. Like they said, consider the product. So the question is you need to find all the values of n for which this is going to be an integer value. So once we find the product, once we multiply these out, we need to solve for n where this is going to be an integer. Okay, let's go ahead and work on this. So with the way this looks, let me just rewrite what we have first. So with the way this looks, to start multiplying it out like this is going to be it's not going to be easy to do that. How do we multiply these two? So why don't we just find out what they would be if you added it individually, added each of these factors. So if you added this one, first of all, so this is the product we're working on. And let's add 1 plus a half. You can use your calculator. That will be 3 over 2. Okay, you can use a calculator. So that one will be 1 times 3, which is 3, plus 1, which is 4, and the denominator stays the same. And this one, 1 times 4 plus 1 is 5, and the denominator stays the same. So this is what it looks like. And what we're going to have to do is find the product. So that's what they said. Consider the product, then tell them the values of n for which the product will be an integer value. So we have to find the product of this. Okay, now with the way this is going, because it's just continuing, we need to know where it ends. We may not have an actual value because it just continues to infinity, but we can actually give it an ending point by using its formula, really. Okay, you see that all of these terms, regardless of what they are, it's always going to be in this form. It's going to be 1 plus 1 over n, meaning 1 plus whatever n is, as long as n is greater than or equal to 2. So the last number could be a big number, but we can't just start giving it a number. We can't say, oh, okay, maybe it's 100, because it doesn't end at 100. So we can't say that. So what we can say it ends at is the last term should be 1 plus 1 over n, okay, because that is the nth term. I say term, but these are factors. They're not really being added together. So with that, and because we already know that n is greater or equal to 2, when we're looking at it here, like when you have to simplify it, when you multiply this out, so we can actually just add this up to find out what exactly the last term is, but we can kind of see what it is already, because here the denominator is 2. So it means the last term that you can get here, right, because it's the last term, would be n, and then the numerator, just follow the way these numerators look. Do you notice that here the denominator here starts at 2? So it's whatever this value n is. And then it just progresses from there. It's a number bigger than that, and then a number bigger than that. But do you notice that the numerator, right, is always one number more than the denominator? You see, 4 is 1 more than 3. 5 is 1 more than 4, and so on. So the numerator would be n plus 1, meaning whatever your last term was, and then plus 1. That's what keeps happening. You could have also added these together and you would have seen that it actually would work. If you said 1 over 1 plus 1 over n, and then make the denominators the same, so you have to multiply that by n, so n over n, and that's going to be n plus 1 over n. See? Okay. But we could also just use logic to get it as well. Okay, so now that we know, okay, we have some sort of an end, it's probably an infinite number, but we have some sort of end. We can actually look at what these factors are doing. Now, these factors, remember, they're being multiplied. What happens when you have a common factor on the numerator and then on the denominator of another fraction? They would cancel. So that's what's going on here. Do you see that if you start from the 3 over 2 and you look at the 4 over 3, the 3 and the 3 would cancel. And then here, the 4 and this 4 would cancel. Here, this 5 and the next 5 would cancel. And with that being said, it's best to actually find the second last term so that we can just see where exactly what cancels, what's going to leave completely. But so long we can see everything is gone here except for the 2. Okay, so let's see what the second last term is. Because it's the previous term, how you're just going to look at it is, if this was n plus 1, then the term before this would just be one number less than what it was. So if this is n plus 1, the previous term would be n plus 1 minus 1, which is n. Okay, over, and then if this is n, it's just going to be exactly what this is, and then minus 1. So it's just a number less than what this was. So that would be n minus 1. Okay, and now looking at this and just seeing what exactly cancels, do you see here that n would cancel with n? That means that you would have had an n minus 1 here cancelling with this n minus 1. And now we're looking at our product and seeing, what does our product give us? Well, our product, we have a denominator of 2 here. Remember, when things cancel, they really just become 1. It's like, it's common with that one, and so it just divides and really just gives you 1. So all three, you can kind of see this as 1s, okay? And they multiply and they will stay 1. And they multiply with this last numerator that did not cancel. This will not cancel, it can't, because it would have only cancelled had you have another term here. Then that one would cancel with the denominator of the next one. But there was no such thing, so it's not cancelling, it's going to stay. So we have n plus 1 there, over, and now what's our denominator? The only denominator that didn't cancel was the 2. So over 2. So this that we have here, we just found the product. Okay, let's make sense of this now. The question is, determine all the values of n for which the product will be an integer value. What would be all the values of n for which this is going to be an integer value? Well, it's n plus 1 over 2. The only way that this can be an integer value, remember that they already told us what n should be, they said n is greater or equal to 2. So let's keep that in mind. So for this to be an integer, because the denominator is 2, the only way it can be an integer is if the top is a number divisible by 2. And numbers divisible by 2 are called even numbers. So n plus 1 will have to be even. Let me first state that. N plus 1 will be even. Okay, must be even, really, for all values of n. Okay, values of n. And we know that this is specifically where n is greater or equal to 2. Okay, but here's the thing. They didn't ask us to solve for n plus 1. They said solve for n. Tell us what n should be so that this will stay an integer. Okay, the only way we can do that is, let's look at what n should be. If n plus 1 must be even, then what should n be? N needs to be an odd number. N must be odd for all values of n, so it's really just the same thing, where n is greater than or equal to 2. Okay, so because if this is even, right, n is definitely odd, because odd number plus 1 gives you an even number. Okay, so that's actually what it should be. And we can test it out. Since I'm saying that n needs to just be an odd number, that is, of course, greater than or equal to 2, then what I'm really saying is n can be numbers like 3, for example, or 5. And let's test this out and see if we plug it into this product that we found, n plus 1 over 2, will it forever give us an integer value? See, if you try 3, 3 plus 1 over 2 gives you 2. Okay, try 5. 5 plus 1 over 2 gives you 3. These are integer values. So that is true. N just has to be odd for all the values of n, of course, where n is greater or equal to 2. And I just noticed that with the n, it doesn't make sense to say n is greater than or equal to 2, because you see, if we are saying that n must be odd, then n can't be 2, because 2 is an even number. N has to be odd, so where n is greater than 2. Okay, so there, n must be odd for all values of n where n is greater than 2. And of course, that will also apply here as well, because if n plus 1 must be even, then this needs to be even. If it's equal to 2, 2 plus 1 is 3, which is odd. Okay, so it needs to stay even, so therefore n must just be greater than 2, not equal to 2. Okay, so that would be the answer there. And that is it for this question 1. I will see you guys in question 2 to 3, which is the sequences and series, and the other parts of this paper, which will be on my channel. Also remember, guys, the chapters are also in the description, so if you wanted to skip to specific questions, you can do that. I wish you guys all the best for paper 2, and I'll see you guys in the next video. Bye.